lab activity. It is reaction between the acid with metals. Here, do you know one thing? At your home, have you seen what pickles or the sour substances stored in the metal containers? Have you seen them? Pickles preserved or stored in the metal containers or metal jars. Why do we use only glass jars or plastic jars? Have you seen them? No one's storing them or preserving them in the metal jars. All are using a glass jars or plastic jars, I think. Yes or no? If yes, give me your response. Preserving them in the glass jars or ceramic jars, right? So why we are using that? We will know the reason for that preserving of pickles, store substances, right? In the metal, sorry, in the plastic or glass jars. Why not in the metals, right? After this reaction or after this lab activity, you are able to answer. So here it is the reaction of acid with the metals. So our aim is to observe the reaction of acid with the metal, right? Then what are the required materials here? Our aim is acid reaction with the metal. So I need one acid and the metal, right? So that two are enough actually, but here acids are liquid substances, right? We are collecting that acids in the liquid form or aqueous solution. So for them we required its container, maybe the beaker or conical flask or the test tube, boiling tube, etc. Right? Here we are unable to handle them directly, right? For that transferring of acids from one to another, we required a dropper, right? So what are the required materials? Here look at test tube required, delivery tubes, right, to connect it. Maybe by the reaction, in a second lesson we learned if a chemical reaction taking place, maybe gases evolves or maybe precipitate forms, heat may be liberates. So here I don't know what may be produced in this. So for that purpose, I am collecting the different types of materials here, right? Not by the expectation, right? Sorry, not by the having idea, just expectation. It may be produced the gases or maybe liberates heat, etc., etc. Hypothetical, assuming, right? So for that, I am collecting the different types of materials. So test tube, delivery tube, glass trough, right? Here on production of gas, we need to pass that into the liquid to test the gas also. So for that, I am collecting glass trough, soap water, right? Candle to test the type of gas, right? Soap water to produce bubbles, to identify the liberation of a gas or to visualize that gas production. We are unable to see the gas directly, right? So liquid produce bubbles in the, when the gas passes into the liquid. When the gas passes into liquids, it produces bubbles. So that purpose I am collecting the soap water. Then acid is required. That is dilute HCl. Here dilute meaning is what? HCl is dangerous, harmful. So for that reason, we are taking dilute. Dilution means that acid concentration is decreased by adding the water, mixing of water and acid. That is the meaning of dilution, right? So these are required, and metal is required. Here I am collecting zinc granules. So these are the required materials. Then let us see the procedure here. What to do? Here procedure, we are observing by the process, step by step. So first step, I am taking a retard stand. In the laboratory, I will take a retard stand. So this is called a retard stand, or it is retard stand. So here, fix a boiling tube to this retard stand. Boiling tube, fix it. So fixed boiling tube here. Fix it to the retard stand. Then what to do? Here, I need to add acid into this. What acid we are taken? Dilute HCl. So with the help of a dropper, add a HCl, right? It may be 10 ml, 5 ml, depending on, right? So I'll take certain amount HCl into the glass tube, right? Boiling tube is filled with dilute HCl. Okay. Then next step here, we are observing the acid reaction with the metal. So I need to add zinc metal pieces into the boiling tube, which contained HCl. So I will drop zinc granules into the test tube, right? Here, before that, I need to set up, because here maybe sometimes the reaction takes place immediately, right? Because here zinc is highly reactive. Zinc is highly reactive. So immediately that reaction may take place. So before that, after filling HCl into the test tube, you need to arrange the other required materials here. What they are here? To test the releasing of gas, we required a soap solution, candle, etc. Right? Then this passing of gas with the help of delivery tube into the soap solution. So for that, I am taking glass beaker that will be filled with the soap solution, right? So I taken soap solution into the beaker. Then here I need to connect that what passing of gases from the delivery tube into the soap solution. So here how do I? Here I need to cover the test tube, right, with the help of a rubber cork. So I will take a single hold rubber cork which is fixed with the delivery tube, right? After dropping zinc granules, immediately fix that boiling tube with the delivery tube, right? So the reaction may take place in that immediately. So before that dropping or while dropping the zinc granules, immediately you need to close this test tube or boiling tube with the help of rubber cork, which is connected with the delivery tube into the soap solution. Immediately close it. Do not allow the gases which may be released in this reaction, right? Which may be released in this reaction. So that is the reason to close this boiling tube after dropping zinc granules. So drop zinc granules, immediately I closed that with the help of a rubber cork containing delivery tube. That delivery tube is connecting boiling tube and the soap solution, right? So here, if the gas is released in this reaction, if the gas may be releases, that gas passes through the delivery tube into the soap solution, right? So here what happens when we add zinc granules into the HCl? The reaction takes place between the zinc granules and HCl. How would I realize that, right? So that realization of reaction between zinc and HCl with the help of bubbles produced in the boiling tube. So that bubbles production in the boiling tube will indicate you that gas is liberating or the reaction is taking place between the zinc and HCl, right? So two things we will learn by the liberation of the reaction of zinc and HCl because of the bubbles formation in the liquid, right? That bubbles in the liquid showing you presence of gas. That is because of what? By the reaction of zinc and HCl. So here the bubbles in the boiling tube guiding us or giving us information that reaction is taking place and a gas is liberating in this reaction. So slowly that gas passes through the delivering tube and reaches the soap solution. So when the gas reaches the soap solution, that bubbles produced in the soap solution, right? So here I need to check that identifying the nature of the gas or the type of gas here. So what may be the liberated gas here? So how do you identify the liberation gas is particular type? It may be carbon dioxide, maybe water, oxygen, or maybe hydrogen. So we have only one test, that is burning matchstick test. If you bring a burning matchstick or a burning candle near the bubbles, what happens? Observe. right? So here I brought a candle with yellow color flame, right? What happened? Here it is changed to blue color flame in the presence of this gas bubbles, right? So that burning with blue flame, sometimes it may be produce the pop sound, right? So burning with blue flame and giving you pop sound indicates the type of gas liberated in this reaction is hydrogen gas. So these are the observations we made in this reaction, right? So here what we can write the reaction here in this, the reaction between zinc granules and HCl is, zinc granules and the HCl is written like this. So acid, HCl is what? Acid. So HCl added by the zinc granules. Then what happened? Here a liquid solution remains in the boiling tube after completion of reaction. Then we observed liberation of gas. So two substances I observed. A liquid remained in the boiling tube and gas liberated. So the liquid remained in the boiling tube is zinc chloride and the gas is hydrogen gas. How would I identify that gas? That gas is identified by the burning a candle, flame test. So flame changed its color into blue. So that is giving me idea about the liberation of a gas. So this is your lab activity. Here in this you are able to write generalized reaction also. How would I write? If you change the acid, maybe you can conduct this activity by taking H2SO4, right? Suppose if you conduct this activity by taking H2SO4, same zinc granules, what happens? The reaction takes place. This zinc displaces hydrogen gas and combines with the sulfate. Then the products are here zinc sulfate and liberation of gas, hydrogen. So whatever it may be, the reaction, right? So here acid, sulfuric acid, or maybe the HCl, right? In this, what happens simply? Salt is produced. In what form? Liquid form. So we can write it as AQ here, aqueous solution of salt. And a gas is liberated, hydrogen gas, right? So now I am able to write the generalized equation here, the reaction between the acid and the metal, the reaction between the acid and metal. What commonly observed here products? It may be zinc chloride or zinc sulfate. What chemically they are here? Salts, right? What they are chemically here? Salts in liquid form obtained, aqueous solutions they are called as. So here I can write the generalized equation here. The reaction between the acid and the metal leads to produce salt and liberation of a gas is called hydrogen. So this is generalized equation. This is generalized equation. Now tell me how you understood this one. Is it clear to everyone? Have you got the experience how to conduct this activity? Give me response. Respond to me. Have you got the experience of laboratory, lab? Yes, right? Okay. So this is the acid reaction with metal. Acid reaction with metal. So here precautions are there. Precautions are there. Can anybody tell me the precautions here? What precautions we need to follow here? What are the precautions we need to take? One is handle the glassware carefully. Handle the glasswares carefully. Then you have acids. You are dealing with acids. What to do? Just take the help of your teacher, right? how to handle the HCl, or dropper helps us. Dropper is used to transfer the acids, right? Don't smell the acids. Don't smell the acids. They are hard and unpleasant. Okay, so these are the precautions we can follow. And do not touch acids. They are corrosive in nature. They are corrosive in nature. These are the precautions we will follow while conduct this activity, right? So compulsory you need to conduct this activity in the presence of teacher, right? So these are the precautions here. Then next, here we observed acid reaction with the metal. Maybe bases also react with the metal. We need to observe that. So that is here activity number 3. That is here activity number 3. So what is activity number 3 here? That is reaction of base with metals. Reaction of base with metals. Here what the bases are? Metal hydroxides or metal oxides, right? So we know already few acids and bases, right? Already in the introduction topics or in the activity 1 we learned which are acids, right? So in the table many are there. From them select at least one base. So here I am selecting that base sodium hydroxide here. So what is my aim here? To observe the reaction between the base and the metal, right? The reaction between the base and the metal. So here is there any reaction we are observing between the base and metal, or maybe the reaction not takes place between them? We don't know. We need to check it, right? So it is to observe the reaction of base with the metal. Then here we need to collect some materials. So required materials. What the required materials are here? So to transfer the bases, or to what having containing them, maybe they are liquids, right? So liquids holded with the test tubes or with the beakers, with the test tubes or with the beakers. So for them we need to collect some glasswares. What they are here? Test tubes or beakers, conical flask, anything which is available. So I'm collecting test tube here. Then delivery tubes, rubber cork, right? So delivery tube is required. Here you need to take delivery tubes, soap water, glass trough, right? So here to hold the soap water or to fill soap water, we need a container, that is glass trough. Then candle to test the liberated gas if releases, right? Then soap solution, finally base, that is what sodium hydroxide solution, right? Zinc granules. So why zinc granules? Because they are highly reactive. Why don't you take iron? Iron is slow reactive, less reaction, right? Here you have reactivity series. That reactivity series is what? Simply the metals which are highly reactive, that are above hydrogen. The reactions which will be given by the metals slowly, less than hydrogen, they are least reactive. That we will learn in the metallurgy, right? So 11th chapter, that we will discuss in detail in 11th chapter. So reactivity series is what? Simply it is arranging the metals in the increasing or decreasing order of reactivity. So maximum decreasing order only, high reactivity elements to, or high reactivity metals to less reactive metals. Above hydrogen, high reactive, below hydrogen, less reactive. So that will give you detailed in a 11th lesson, right? So I collected the required materials here. I collected required materials, right? Okay, Sri Charan, have you got answer for your question? Why not magnesium? I didn't observe your question. Is it clear now?
Yes, sir.
So here, metals reaction is not same. Some are highly reactive, some are moderate, some are least reactive, right? So that is the reason. Okay, here we got answer for that, our procedure. So for the procedure, I required here Bunsen burner. Why, sir? Why not you are taken in the previous activity, especially you are taking in this? Have you seen the difference between the base and acid here? Base is NaOH, acid is HCl, right? What is the difference in this? Here, I have a metal. Here, completely non-metals, right? There are no metals in acids. There is a metal in the bases, right? So here, reaction is observed between acid and base. So one containing metal, other containing non-metals. Now here you are observing the reaction between metal and metal hydroxide. Both are having the metals. Now only I said about reactivity series, right? Reactivity series. So here, zinc and sodium both are highly reactive. Both are highly reactive. So here, to fasten the reaction or to speed up the reaction, sometimes you may require heat energy or certain temperature pressure conditions, STP, standard temperature and pressure. So that is the reason to collect a special material here, Bunsen burner, right, to provide the heat energy, right? So this is the reason. Okay. Now, how to arrange that and how to connect this, both I will explain you at a time. So procedure. So very first, we are taking the stand, fixing the boiling tube, right? Fix it to the retort stand or laboratory stand, then fill it with the base now, right? In the test tube, fill a base. So what is the base here now? It is sodium hydroxide. What we are taking? Sodium hydroxide, which is basic in nature. Then what to do? Here, we need to drop a metal. So before dropping the metal, I need to set up remaining materials, right? So here, just connect delivery tube into the soap solution. So I need soap solution. For that, I'm using a glass trough, fill it with the soap water, then drop the zinc granules. After dropping, immediately cover the boiling tube with rubber cork connecting with the delivery tubes, right? So just heat these contents. Heat this contents. So reaction is taking place. So immediately connect that. Then what happens? The reaction is taking place in the presence of heat energy. The reaction is taking place in the presence of heat energy here. So that gas is slowly transferred into the soap solution, creating bubbles in the soap water. Then you need to check this gas nature. So bring that burning candle towards these bubbles. Then what do you notice? Observe. Again, here I observed blue colored flame. Candle is burning with the blue color flame and giving you pop sound. So this is indicating us the liberation of gas type is hydrogen gas. What the type of gas here? Hydrogen gas. How I know that? Because of that flame of candle changed into blue color and produces pop sound. So this is observation, or this is indication to identify the type of gas is hydrogen. So here, can you write the equation for this reaction? Yes, we are able to write because the reaction is observed. So what changes you notice here? Liberation of gas. Change is observed. So that change is indicating reaction is taking place, right? So sometimes that reactions are maybe slower. To speed up, you need sometimes a special substance which do not participate in the reaction and increases the rate of reaction called a catalyst. Or sometimes you need to provide heat energy, that is by using Bunsen burner, right? Provides heat energy. So while heating that contents, the reaction is taking place, liberating the carbon dioxide. That carbon dioxide is passing into the soap solution with the help through the delivery tube, right? Then I brought a candle, right? We know the candle flame, orange or reddish orange color, that changed into bluish color. That because of liberation of gas here, that gas is identified as hydrogen gas. So now I am able to know the products here. What are the products? Two products are there. One is liquid remains in the boiling tube after reaction. So that completely different characteristic comparing with the basic solution NaOH, and a gas is escaped. So two products are there. One is liquid and gas. So what are the reactants here? NaOH and zinc, base and metal. So that two are producing here. What? One liquid aqueous solution. What aqueous solution is here? That is the reaction of sodium hydroxide and zinc produced. That aqueous solution is here sodium zincate. Sodium zincate, Na2ZnO2, and liberated a gas identified by me as hydrogen gas. So this is equation for the reaction. So remember the formula: sodium zincate, Na2ZnO2, objective bit. Okay, so here simply I am written the equation. Sir, why not with the other substances, sir? Yes, you can complete this reaction with other also, by taking potassium hydroxide, by taking NGOH2 or calcium hydroxide. So respective to that salt, you will get different substances here. For example, here I can give you one more example by taking a calcium hydroxide, CaOH2. It is base, same metal piece, okay, Zn, highly reactive comparing with the calcium. So what are the products you are expecting here? What are the products you are expecting here? Right, that is calcium zincate. Formula is Ca2ZnO2 and liberating the hydrogen. If you take one more aluminum hydroxide, AlOH2 with a metal, or what another possible, zinc with a calcium, calcium, many are there, you can take any other, right? So search for them, I'm not giving you, right? So one example is given, that is by calcium hydroxide and zinc producing calcium zincate and liberating the gas hydrogen. So process is same, no change in the process, right? So many examples you are able to collect. Only one example is given in your textbook. One more I am given, add into your textbook, right? Don't prepare this. If that something differently asked in your examination, it will help you to write another example, right? So this is, so far from this, what I'm able to generalize here, whatever it may be, if the base reacting with a metal, what happens? Base reacting with a metal, producing aqueous solution of salt and liberating the gas. So I am able to write generalized equation for this reaction, right? So generalized form of above chemical reaction is simply base reaction with zinc, that is metal. So base with metal producing salt and liberating the gas called hydrogen. So this is generalized reaction. Is it clear, everyone?